I changed the title slightly from what was presented, but it's because I was putting this talk together and I realized that actually what I wanted to share today went far beyond heritage buildings. It's actually much more generally. I also just want to take the opportunity to thank Hutton and Rostron for inviting me to speak today. It's really a privilege, and looking at the other speakers from yesterday and today, it's quite an honor to be among such wonderful colleagues. I reminded Robin Pender that we met 10 years ago next month, so it's been a long time. What I'm not going to talk about today is what the biggest risks of climate change are to heritage buildings or any other buildings. To be honest, I'm not sure that we have a really definitive idea of what that is. It also would differ if you were going to look at the UK context specifically, or if you were looking at other contexts. What I do want to do is try and give us a common language to talk about climate change. In what I read and what I see and when I speak to people, I find that we're all using different languages. We're not using the terminology or the understanding of concepts that are used more broadly in climate change, and that's holding us back from working with other colleagues, but even just talking within our own community. So that's really what I want to focus on today, is how we think and talk about climate change. Perhaps the very first point, here's a quote from two wonderful colleagues in the climate change and heritage sphere, and they argue that climate change should now be a primary lens through which conservation and management of cultural heritage is viewed. I actually don't know if I agree with this, but I think it's a really interesting point that effectively what's happened is that our discussions around climate and weather and the impacts these have on the built environment is effectively now seen through the lens of climate change. And we very often say climate change is causing this. What I want to emphasize here is that I will be talking about climate change in this presentation, not climate, of which I actually think people in this room know far more than I do. So we're going to focus on the change aspect of this. So what I want to do today is introduce some key concepts about climate change, how we talk about it, how we think about it, a little bit about how we understand the risks of climate change for the built environment, but actually more generally, and a few current perspectives on climate change risks for buildings. So some key concepts. This is a little bit lecture, I thought, in format, but hopefully that's all right. There's two kind of key organizations I wanted to highlight. The IPCC is the Intergovernmental Panel on Climate Change. Officially, the goal of the IPCC is to synthesize evidence, our scientific understanding of climate change from a physical sense, so physical science, the impact it has and how we try to adapt to it, and how we mitigate climate change. So what the IPCC isn't is a negotiating body. It's not an organization that tries to influence practice or policy. It simply summarizes evidence. There are two interesting challenges here, one of which is that when it says evidence, it means peer-reviewed academic publications. So one of the biggest challenges here is getting sort of practice-led knowledge into our understanding of climate change. Technical reports would not count. Surveys would not count as evidence in the eyes of the IPCC. And I think that's a really big challenge for the built environment sector, to make sure that we're coming together to talk about these things. And one other interesting point is that it makes a distinction between adaptation, so responding to the already observed effects of climate change, and mitigation, so thinking about, for example, reducing energy consumption or improving energy efficiency to lower the associated carbon emissions with operations in the built environment. So adaptation and mitigation as two very separate concepts is an interesting idea here. The other organization, which I meant to have a definition for, but I'll explain, is the UNFCCC. So this is the UN Framework Convention on Climate Change. This is a very different organization. This is the one that organizes the Conference of the Parties. So we're coming up on COP29, which I can't remember where it's being held. This is confusingly organized by the same organizations that run the IPCC, but with a very different purpose, which is to be a negotiating and agreement body. And they are very influential when it comes to politics and policies. And perhaps the most interesting thing between them is that they have fundamentally different definitions of climate change. So one of them, that being the UNFCCC, looks at the aspects of changes of climate that are directly or indirectly attributed to human activity. And I would argue in the built environment, this is the definition of climate change we use. We are implicitly talking about the changes in climate we see because of human activities. Interestingly, the IPCC, which is again the more scientific, supposedly impartial body, is more or less looking at long-term changes in climate, regardless of what the cause is. So that, for example, is much more interested in longer term, for example, even prehistoric or geological climate change. But I think it's a really important thing just to be aware of, that when we're talking about climate change in the built environment, we implicitly mean this UNFCCC, the one that is directly or indirectly attributed to human activities. And it is a different relationship to the environment than the other one. Some other definitions are a little bit heavy on definitions, but I'll try and make them somewhat interesting. We use the word impacts a lot. Interestingly, impacts doesn't actually have an official definition in the IPCC glossary, but you can more or less think about them as the consequences of realized risks. So they are things that we directly observe as the outcomes of climate change. And it's nice to see that cultural assets is actually included in this particular definition. And impacts might be referred to as consequences or outcomes. And I think really importantly, they can be adverse, they can be negative, but they can also be positive. There are things happening due to anthropogenic climate change that will benefit the performance of the built environment. We tend to only talk negatively about climate change. And if we do that, we're restricting ourselves to actually a narrow view. And I want to be very clear that this is in no way a denial of climate change, but it's simply a reframing of some of the impacts of it as ones that may actually be beneficial for certain aspects of the operation of the built environment. Another one looking at adaptation pathways, which is a concept becoming quite prevalent in discussions. These are looking at adaptation choices when it comes to how we make things. So the view that we're not making decisions today to deal with the impacts of climate change indefinitely, but we have a series of decisions that we make at different points. And how and when we make those decisions is still quite an interesting question, I think, in terms of how we design adaptation pathways for the built environment. So when we think about climate change, we have to realize that we're always talking about scenarios. There's an incredible amount of work that happens globally to understand what those scenarios look like and what is likely to occur, or when you start to get into statistical language, what is very likely, highly likely, somewhat likely. Here are 4 different ones. And I think the fact that we have so many different options when it comes to talking about climate change is a benefit, but it's also a challenge for us. So here, for example, are 4 examples. You might be familiar with the term RCPs. These are the representative concentration pathways. Less commonly known are essentially the longer term extensions of those, the ECPs, but also socioeconomic pathways. Perhaps these aren't as familiar to you, and degrees of warming. All 4 of these are different systems to think about the different scenarios of climate change that we might be looking at in the future. And they're all interchangeable to some extent, but it's a bit like translating languages. If you've ever used Google Translate, if you're bilingual, you find some of the translations funny because you have to make an assumption, or the underlying artificial intelligence isn't very good at capturing the nuance. So translating between these is possible, but not perfect for some of the reasons that I'll look at in a second. So the RCPs are often referred to as numbers. So RCP 2.6, and I think this is often mistaken with 2.6 degrees of global warming. These are actually looking at radiative forcings. So effectively, we have 4 different common representative concentration pathways. These are 4 different realistic scenarios of how much radiative forcing will change up to 2100. So you might often see these, for example, if you've worked with climate projections available from something like UKCP18 or other climate scenario models. But I think knowing that one of the challenges of working with RCPs is that although they're scientifically useful for modeling, it's very difficult to know what RCP 8.5 is. And that's sort of being the worst case scenario that we see in the 21st century. It's the one that's most commonly used in a lot of the climate projections or sort of modeling of impacts on the built environment, but rarely communicated as the absolute worst case scenario that we expect in the next century. The extended concentration pathways are really just what happens after 2100 in those different scenarios. So these are actually looking at the idea that, 2100 was really proposed as something that made sense at the beginning of the 21st century, but the idea that we should also be thinking about looking further ahead, particularly with heritage, historic, or traditional buildings that have much longer lifespans than perhaps typical 60-year design lives. The idea of extending concentration pathways is something that we should be thinking about. The shared socioeconomic pathways are interesting because effectively they were developed to complement the representative concentration pathways, but looking at the socioeconomic challenges of adaptation and mitigation. So effectively, they cover 5 different economic or socioeconomic options that exist for the next century. So the one is that we have very sustainable development. This is a sort of ideal green case. And then we kind of progress towards more fossil fuel intensive development. So effectively, you can think about SSP5 being equivalent to the 8.5 RCP scenario, but they're not directly translatable. But I think this is a really interesting one because it recognizes that the human aspect of these different possible scenarios that we'll see is really crucial. And there's a whole bunch of things on this you can look at. So they talk quite a bit about the potential for disruptive technologies, for the intersectionality with different kind of global challenges. So these are worth looking at if you're trying to understand the more human aspect of adaptation and mitigation for climate change. The degrees of warming, I think, is an interesting one. So those of you who know some aspects of climate policy might be familiar with the Paris Agreement. You know, that was a landmark decision. It took quite a long time to get there. And really, the goal of that was to limit global warming to 1.5 degrees above pre-industrial levels. You'll notice here that the shared socioeconomic pathway 1, which is the really sustainable development one, is still above 1.5 degrees in some of the most recent projections. But these gives you an example where, for example, maybe I'll use the cursor, it's probably easier. Yeah, so here, looking at how we translate it's a touch screen, how we translate the socioeconomic pathways into different potential RCP scenarios and degrees of warming. And so these figures here, the details are not so important, but I think what is well demonstrated here is the challenge of trying to translate between these systems. So if, for example, you're interested in 2.5 degrees of warming, there are a number of ways that we might get there and at different times. So in terms of how you start to think about planning, or you look at multi-decade decision-making, the fact that you might be planning for a 2.5 degree scenario in 30 years is very different than that which might be in 50 years or in 15 years. So the challenge between translating between all of these systems is that you have to look at time as one of the biggest unknowns, because it really depends what scenario and which pathways and trajectories we follow. Some other maybe interesting challenges highlighted here is that the Paris Agreement looked at pre-industrial levels, so that was set between 1850 and 1900. But we also have very different baselines. You may have your own baselines that you want to use. They may be operational in terms of particular organization, or it could be a baseline of sort of pre-post retrofit. And that makes it really challenging to compare advantages and changes when we all have different baselines. And I don't have a proposal for a particular one that makes sense, except that it would be interesting to think about trying to agree one or adopting baselines that are more prevalent in other sectors, for example. When we think about this degree of warming, I've heard people say in the past, 1.5 degrees isn't that much, just a little bit warmer, right? This might be obvious to many of you, but I think it's always worth emphasizing that, of course, a global average temperature, such as the figure 1.5 we use in reference to the Paris Agreement, is a kind of a global average climate, which is based on 30 years averaging time window. But what that translates into is very regional changes in the severity of particular kinds of local weather patterns. So for example, looking at the change in temperature of the average hottest days, we can look at many parts of the world with the implication of 10 degrees increases on some of the hottest days in that 1.5 scenario, if that makes sense. So the global average temperature doesn't tell us about what happens on individual given days or individual scenarios of particular weather events. I always think this is an interesting one to think about. Why does climate change cause more extreme weather? I don't know if anyone has any thoughts on some of these, or if you've ever thought a little bit about this. I'm seeing flippers. Exactly. So, I mean, really the key here is to think about the globe as a system, right? And the system has a certain amount of energy in it. When you bring in different amounts of energy, then all of a sudden things become out of balance. I don't know if anybody wants to take a stab at trying to explain any of these particular environmental phenomena and why they change when it comes to why climate change would affect them. Maybe just take a minute to think about one of them and see if you can rationalize it. Some are more obvious than others. For example, we have with increased temperatures, the air can hold more water vapor. So in some cases, that results in reduced relative humidity, but it also means that there's a greater buildup of water in water vapor that can lead to heavier precipitation events. It's quite interesting to rationalize these because, of course, they happen at different periods of the year. So you can have both increases in precipitation and reduced relative humidity, which sounds quite counterintuitive, but is the reality of how the globe works as a system. I also like that the snowfall increases. It's maybe not so relevant for the UK, but in other parts of the world, certainly we're looking at that implication. So I just wanted to speak a little bit about the risks of climate change. That was sort of finishing up before with some key concepts and definitions, but I encourage you to have a look further at some of the summary guidance that organizations like the IPCC produce. When we think about risk assessment, I imagine this is a concept very established for most of you. But the idea in a climate change context is trying to answer the questions of what is going to happen, why does that matter? And for example, you can look at the ISO standards on risk assessment. So it's a process to comprehend the nature of the risk and determine the level of risk. One of the things that I've always thought was interesting about risk in a heritage, but also in a kind of built environment context, is that we tend to use quite straightforward representations of risk. So for example, there'll be the very common two-dimensional grids, and you have the sort of the severity of the event and the likelihood of occurrence, right? Has anyone used these kinds of frameworks? The really interesting thing about those is that they actually end up being risk neutral. So they assume that, of course, you can have an equivalence between a low likelihood, high severity, or a low severity, high likelihood event, that they're equally risk. So it assumes the person who makes the decision is risk neutral, that they see those as equivalent risks. In reality, it's much better to separate out the frequency and severity. Although these sort of simple traffic-like systems are convenient, they've been described as sort of basically less than taking a decision at random, because they don't actually help us make informed decisions about risk. So I think it's a really interesting concept when we think about risk assessment in a climate change context, because we need to be thinking about the frequency and severity separately. And I think most importantly, asking who is going to make those decisions. So when you provide evidence in this risk assessment context, who is that actually for? And what is the level of acceptable risk that they might be looking at, or their particular interests when it comes to risk? These will not come as a surprise to some extent, but I think it's interesting to highlight that when we look at how we assess the risks of climate change right now for different instances or contexts, most risk assessments are done for single sites. So for example, this was one done by Historic Environment Scotland a few years ago, which they actually used the CVI methodology, which I'll come to in a bit. And those of you who know the literature in this area relatively well will know that Historic Environment Scotland also took a portfolio approach. So they actually did very relatively light touch assessments across all of their properties and care, something like 330 of them, and tried to understand which would be most affected or impacted by climate change. But we can also look at the landscape scale of this, right? So thinking about the opportunities for geospatial approaches and taking a wider aspect and thinking about that. Is anyone familiar with the Climate Vulnerability Index, the CVI? Yeah, one hand, okay. A few others, well done, great. I have to say that I'm not a great expert in it, and I haven't applied the CVI, but I think it's an interesting one to highlight because it really it was originally designed for World Heritage properties, although it has now been applied in other contexts, particularly looking at some sites in Africa by a recent project. It's supposed to be a rapid assessment tool. I think that depends on what your definition of rapid is. It's actually still quite an involved process, but maybe that's not a bad thing. I think what the CVI does particularly well is that it recognizes that the community and the people are an essential part of the risk assessment. Very often when you say a term like, I'm going to do a risk assessment of climate change, it means I'm going to look at some changes in the physical environment and talk about the implications for a building. And I think what's nice about the CVI approach is recognizing the aspect of community in that, and particularly looks at the vulnerability. Now, community in this case is a very World Heritage concept, but I think thinking about how that relates to owners, occupants, and stakeholders in a building is a really important part of thinking about climate change risk. I mentioned earlier that I would encourage everyone to adopt sort of standardized approaches. So at least not just having standard understandings of the different terms that we use in a climate change context and the concepts that we're looking to, but also perhaps adopting common frameworks and methods. This isn't as straightforward as it might sound, because the idea of risk and understanding of risk in the climate change sector is also rapidly changing. So here I have 4 versions of basically official published risk frameworks from different IPCC reports. So the first one starting in 2007, that was the 4th assessment report cycle, coming through the numeric cycles with a special report in the middle, coming to the most recent one, which is the 6th assessment report published in 2022. And what you can see here is that there's some kind of main ideas that remain central to the idea of risk, but they're also changing their understanding of what climate change risk looks like and how you represent it. So interestingly, the CVI, because of when it was first developed, uses the risk framework from AR4, which is simply a nature of how it was developed. That's when it was established, and still the CVI methodology uses the understanding of risk from 2007. So one of the challenges for heritage is that or buildings as well, is that when the CVI becomes more and more prevalent, or when it's used, is that it's no longer speaking to the understanding of risk that the kind of global climate change world is using. And it's one of the challenges. I think the other thing that this represents is that there's some key concepts when it comes to things we want to represent in risk. We already, for example, talked about the frequency severity model. There are many of them. I think one of the challenges is that they're actually quite difficult to pin down in terms of the definitions or concepts that we want to represent in risk. So we might say, for example, that something is exposed and vulnerable and means sort of the same thing. To someone who works very closely with IPCC methodologies and concepts, to be exposed and to be vulnerable are absolutely different things. I don't know if anyone has any thoughts on whether this is semantic or if it's important. Personally, I would argue that it's quite important. So the current IPCC risk framework really has 4 main determinants of risk. So different aspects that we should be thinking about. The first one being the hazards that occur. So these are the potential occurrence of a physical phenomenon that causes change. And you notice that that definition of a hazard is neutral, right? So that could be with an adverse impact, or it could have a beneficial impact. So the idea of hazard as really just the physical things that change, and that's the potential occurrence of it. So in a scenario context that we don't necessarily know exactly what will happen. We can also look at the exposure. So to be exposed is the presence and characteristics of, in this case, I've put cultural heritage because I stole this slide from a lecture, but let's talk about the built environment. So the exposure is interesting because you can look at all the possible physical elements in a building. You could look at the ones that are valued or perhaps have particular protections on them. Obviously, in listed structures, that's particularly relevant. But you also have to think about how much you would have to understand about the physical materials and the nature of the construction to actually characterize the exposure of a building. The vulnerability is the predisposition to be affected. So for example, you might argue that a building constructed in a particularly weak type of stone is more vulnerable to particular kinds of weather events than another. Or for example, a building with very poor gutter maintenance or no gutters at all is more vulnerable than one without it. But it's not more exposed because if you put the two buildings in the same place and they were exposed to the same hazards, then they have the same exposure. I found when I first started to get my head around this risk framework that I found it very difficult to separate out these determinants. But I encourage you to next time you're at a site or just on the bus, as I was doing this morning, try to take examples and separate out what the different determinants are of the risk in a climate change context. One of the most interesting aspects that was added in the AR6 risk framework is response as part of the risk of climate change. This effectively is looking at the actions or lack of actions that directly change the level of risk. So one of the most common examples that I think is being talked about now in the built context is solid wall retrofit and the risks that introduces when it comes to moisture or long-term changes in moisture regimes. That is a risk of the response to climate change, i.e. in trying to mitigate, trying to make buildings more energy efficient, we potentially introduce other risks. So the risks of response. What this very fancy diagram on the right generally tries to introduce the idea of is that all of these determinants interact with each other and that they are really part of a system. So by bringing them all together, we can try and capture the risks of climate change holistically. So I just wanted to spend maybe a minute or two. This is an aerial shot of Iona Abbey near the west coast of Scotland. And I just wanted to take a minute to try to undertake this exercise. So in this context, I know I've just shown an image. I hope you know enough about Iona to get a sense of it. What are the different determinants here? So what are the hazards that would be facing this particular context? I won't ask for volunteers because I think roving mics is a bit complicated, but just take a minute to think about it or talk to the person next to you. What would be the hazards in this context that might be affecting Iona Abbey and the surrounded buildings? Yeah, so we can look at rising sea levels, yeah. So I think that's an impact. So I think the sea levels is good because that would affect how moisture is interacting with the structure, right? I see. Hmm. Yeah, and I think the properties of the bricks that you mentioned, in this case, it's constructed of stone, but I think that is really looking at the vulnerability as the characteristics of those bricks, and they have their implicit behavior of how they uptake water and then release it in different seasons. And the exposure, of course, is the nature of that construction. Can you say it again? Sorry. Yeah, so that's another hazard we might be interested in, right? Yeah. Hmm. Hmm. It's a really interesting point. I have a slide that will be relevant, so I'll come back to this example in a little bit. And I think with the response, it's a really interesting one. So thinking about how you might make adaptation recommendations for a site like this and what the potential risks are from doing that or from doing nothing. For example, if you're waiting for a better product to come on the market, if you're waiting for a better understanding, what are the risks of the lack of response that might emerge? There's another concept that I didn't introduce, which is the idea of a climate impact driver. These are really the sort of fundamental aspects of the climate system that then cause hazards. So I have an example here because it's quite difficult to get my head around these things sometimes. So for example, the IPCC has, I think, 7 or 8 categories of different climate impact drivers. these are the things that fundamentally affect the climate system. So for example, the mean wind speed. So this is where it gets really tricky, because you might say that when there are high wind speed events, that's a hazard because it affects my buildings. There's some sort of damage done. But the mean wind speed, for example, is the driver of different specific hazards. So when we talk about hazards for the built environment, we actually have our own set of interests. For example, very few other people care about wind-driven rain as a topic. It's a very built environment specific hazard that's related to precipitation patterns and to wind speeds. But it's a very specific hazard that we are interested in that most people do not care about. And the impact of that wind-driven rain might be water penetration. So when you say there's the risk of water penetration, that's actually the impact. It's not the risk, if that makes sense. This might all sound semantic, but I think it's really important to recognize when these terms are neutral, when we are implicitly talking about negative adverse consequences, and which are the things that the IPCC has said, this is the set of parameters in the system that we know about, and we have to look at the hazards which are specific to the built environment. And often I find the gap when it comes to risk assessment in climate change is moving from the impact drivers. For example, there's a lot of information out there about mean wind speed or changes in precipitation, but the gap is translating that into our understanding of wind-driven rain as an example of a built environment specific hazard. And even more complicatedly, how that actually changes patterns of water penetration. We have been trying to make some inroads in this. So I'd like to shamelessly plug a publication that we co-authored with Historic England. I don't think any of them are here today. But we were effectively trying to look at developing a vocabulary of climate change hazards for heritage. It started out looking at historic buildings, but then we realized that actually in a way that many of the principles I was trying to introduce here today, they actually are much broader. They can be looked at for landscapes as well, or sites with different typologies in them. So what this basically tried to do was to build on the climate impact drivers as presented by the IPCC and develop a specific vocabulary that was controlled so that we could have some sort of definitions for climate change in this context. So have a look at that. It's a technical report, open access, available from Historic England. I think one of the most interesting things is this is the example I wanted to come back to with changing precipitation, is that there's many different ways that we can look at different hazards. So for example, if we talk about just precipitation levels, not specifically wind-driven rain, these are 6 different ways in which you might think about hazards changing, right? So in this case, we were talking about the intensity. So we were talking about heavy precipitation events in Gibraltar, right? But we might also think about the frequency of the severity events we already see, right? And we might actually be looking at something that says they're both more intense and more frequent. In fact, that's not generally what is thought about wind-driven rain events or rain events more broadly. We're seeing, interestingly, about the same amount of rain in an annual period, but distributed differently. So in more intense and less frequent periods, which has implications. We might also be thinking about durations. So I don't need to go through all 6 of these, I think, but the idea is to understand in a systematic way all the potential changes and hazards that might have implications for the risks of climate change in a particular context. So thinking about not just severity or intensity, not how frequently things are occurring, not just the duration, which could be longer or shorter, thinking about seasonal shifts as well. And that's something that was already mentioned here in terms of the implications of one season on another and on how that affects the annual behavior of particular building materials. It could also be a shift in the speed of onset and the spatial extent. So even when you're looking at one particular hazard, it's worth trying to think about the potential changes in any of these, and perhaps the risks emerge from combinations of them. How am I doing on time? I've got about 5 minutes left, I think. Yeah, great. I have 2 or 3 slides left. This was just some semi-collected thoughts on climate change risks for buildings. I think there's some limitations of the recent approaches that have been taken. Perhaps the foremost one I see is that we have a lack of evidence for the risks of climate change specifically. And I think this is specific to the built environment, that there's lots of work done on how the climate is changing, those overall climate impact drivers, but not specifically in the hazards that we're interested in when it comes to the built environment. Or we talk about hypothetical risks. So we say an increase in humidity causes this, but we don't necessarily know in terms of our hazard profiles where, when, and to what extent those patterns are actually happening. We have a very poor understanding of what climate change is going to do to these conditions, not just climate and not what is possible. We have a very good theoretical understanding of the interactions between the physical built environment and the environment that causes adverse consequences. So we tend to focus on environmental risks and impacts of weather, the vulnerability. So that's essentially the other side of the same coin, the one I just mentioned, that there is a lot of fundamental understanding, research, and practical experience that we can build on there, but trying to connect it to the change in climate is another challenge. I started off by mentioning this aspect of inconsistent terminology, talking about exposure and vulnerability, for example, interchangeably, and relatively limited conceptualizations of risk, which is something I'll come back to in a second. And I think one of the biggest challenges for us is that the information, the summaries of climate and the tools that are out there are not necessarily tailored to assessing risk for buildings, which means that you either have to do quite a lot of work to get information in the right format to make it useful for making decisions, or you just don't do it at all. And something we should try and feed back and argue for and advocate for. This is just something to think about, which is that it's easy to think about risks individually. So you assess the risk of wind-driven rain penetration, you assess the risk of landslides, you assess the risk of sea level rise, and then you present them. This is the set of risks and how severe and likely they all are. But of course, these things interact, right? So I really like this figure produced by a colleague of mine based in Cape Town, where in the simplest model, you can say that each one of those, for example, sea level rise, wind-driven rain, and landslides, together they present an aggregated risk of climate change, right? So you might say, we picked these 3 out of the 10 we looked at, which are going to be the ones that change the most in the next 30 years. So they have an aggregate risk of this. But you can also look at how these risks interact with each other, right? So it might be that I'm going to see if this works out of my example now. I didn't think this through. But you might say that, for example, a landslide changes the local topography, and therefore the sheltering from wind-driven rain no longer applies. So in one way, one risk has changed the risk of another particular hazard. And that also might be a bi-directional risk. Perhaps the one that I think is most challenging to represent is the idea of a cascading risk. So where you have, might start out with a unidirectional aspect of risk, but then you end up having a whole set of things that come out from that. And trying to design an adaptation decision-making pathway to represent that cascading nature of risk is very, very complex. I don't have answers for that, sorry. This is another one that I think is really interesting. The uncertainty. What is presented here is essentially 6 different levels of uncertainty that you might have when it comes to any sort of, I'll say, scientific evidence or technical understanding. It might be ambiguous, so you might not really know what effect a particular hazard or change in the environment has on the built environment. Or you might know of proportionality. So the more wind-driven rain there is, the more moisture there is in a building material. That's a proportionality, right? I would say a lot of our understanding of the interactions between the built environment and the external environment are proportionality. We know if one thing goes up, something else goes up, or if something goes up, something goes down. How much it does that? We say, oh, it depends, or it's complicated, or we'd have to build a model or measure for a few years. In some cases, it might be possible to have an order of magnitude. So you might know that when wind-driven rain reaches a certain threshold, then we see a certain moisture content in these materials. That's already pushing, I think, some of the boundaries of our understanding. So if you had infinite resources, infinite time and money, you can develop really statistically robust distributions of the probability of different risks, right? You could do, tens of thousands of simulations. You could look at every building in a particular region, and you could develop this. We don't have the resources, right? So I guess what I find interesting about uncertainty in the climate change risk context is how much do we need to know to actually make decisions now without potentially raising significant risks of response? And again, it's not something I have an answer to, but I think it's a really interesting one. And I might argue that the proportionality we have, understanding when one thing goes up, that something else goes up or down, might be enough to make some decisions. I'm very glad Robin is approving with her head. And I think it's also interesting just to highlight that there is still uncertainty in our understanding of climate change. And we have to recognize that although it's very nice to take scenarios as facts, and it's very convenient to use very clean and crisp numbers, that the uncertainty is not only on our side when it comes to the built environment, but also on the climate side. And everything we do could be out of date in 5 years or in 2 years. Who knows? It's a bit bleak, isn't it? Just 4 final very quick points. So I think if I had to make some recommendations or requests from you as a very kind audience, is to get on the same page about how we talk about climate change. So think about who has already done some groundwork out there in terms of talking about different aspects of climate change, and see if we can use their language to talk with them, but also talk within ourselves. Focus on climate change, not on climate, if you want to look at climate change. Obviously, understanding weather and climate is still a very important aspect of built environment performance. Think about the different components, determinants, and aspects of risk, and particularly thinking about the response, the risks of response, and push for more evidence about the impacts of climate change to the built environment. I think the more that we can complain about what we have, the more we can make a case that we need to better understand. So if you do nothing else today, take one of these and do it. That's my only request. Thanks very much.